delighted to have Snehal Chakandra and Ahmet Erdemir here to share with us what they've been doing to create very comprehensive open source data sets specifically in the knee, but also to learn a little bit more about what goes into creating these open source data sets and how we as researchers might contribute, but also how we might take advantage of and use this in our own research. So I'll, with no further ado, hand it over to Snehal to show her slides and share with us their work.
Awesome.
And if you have questions during the presentation, feel free to put them in the chat, and I'll go ahead and let Snehal know that they're happening, and she can pause and answer them as she's going. Or if you want to save them to the end, that's okay too.
Can you see my screen? Can you see my screen?
I can see your full screen, so I can see the whole PowerPoint folder rather than the share screen.
Okay, now
that is perfect. Yeah. Yes.
All right, awesome. So thank you so much for having us today. We are very excited to talk about our work and the importance of sharing research resources with the community. And even though the theme of today's presentation is an open source data set, but it is important to think a little bit beyond data and think about the larger resources, and also understanding that open science thrives on collaboration. So I'll be talking a little bit about how to build these open source resources, and also how to bring the community in to bring their input in and build this collectively. And I'll speak from the perspective of our work and our efforts to build open source resources for the computational biomechanics community, and then how we brought the community together to address some of the challenges, and we continue to do so. So the question is, why should I share what I'm building? Whether it's data, it's models, tools, workflows, whatever that you're building. It takes a lot of work. It takes a lot of time and money to gather and build these things. So, and that's precisely why we should share these, because as and when we can, because collectively we can reduce a lot of the individual burden of these resources if they're shared appropriately. So, and then several people may not be doing the same thing over and over again. If we have the right foundational material available, whether it's data, and so when we build model, in our case, say for example, with segmentations and the foundation that go along with it, it can speed up hypothesis testing. You can accelerate research, and of course, when these resources are available to at a larger scale, because of the collaborative nature. There are several different labs trying to build something together. There's more people are willing to share their resources, and it can enable larger scale accelerated research and translation. And that's what we're trying to accomplish here. And of course, there's this inherent advantage that levels the playing field. If you have these open source resources available to the larger audience. Whether you work at a top institution or you work at a small school in a developing country, if you have access to the same resources, you have the same starting point. Because as we'll talk about what goes into building these models that we build, you'll see that it is, and a lot of you are already doing this, so you're fairly familiar with the amount of effort and the resources that go into this. And that's why it's also important that we build these appropriately and share these appropriately, so it reaches a larger community, and we all can collectively benefit from that. And also when we build this together and we build this infrastructure collectively that others can use, share, and build upon, this work can live on, because there's a chance that somebody else might carry what you're doing forward, because we don't always have the luxury to continue what we're doing. People change path, the motivations change, people build and move on. When you have the input of a community, when you have a larger support system built around what you're building, you're ensuring the longevity that your work remains relevant, and then people can continue to use what you've built for years and years to come. So when you decide that you want to share resources, whether it's data, it's models, etc., and there's certain things that you have to keep in mind, so that what you're sharing is not misinterpreted, it's not misused, and it is actually useful, and somebody can take that as a reliable foundation and build their work on top of that. So so when you're thinking about sharing your resources, you should follow the FAIR principles. So what is that? So which means the data should be findable. So use clear identification, use proper DOIs, so the asset is discoverable by both humans and machines. They should be accessible, meaning that could be made available through repositories that have authentication and authorization can be managed if needed. The resources of the data should be interoperable, meaning use standard formats, use vocabularies and ontologies that are common and shared. So for example, use DICOM for imaging data, for example. And they should be reusable. The resources should be reusable. So use appropriate licensing, use appropriate and detailed documentation and guidelines. So others can use these resources in a meaningful way, and you avoid misuse or misinterpretation of what you're doing. And you don't want to limit it too much either. So it's important to maintain integrity and fidelity of your open source resources. A lot of times people who are building this is, they're smaller teams. There's always a chance that you are, you miss something, but you have to do your best to maintain accuracy. You should be consistent. Yeah, it should be, what you're building should be easy to use, easy to follow, easy to interpret. Hopefully, avoid deleting something that would break the continuity or the completeness of what you're providing, for example. Use version control. It's extremely useful to keep track of the changes you've made along the life cycle. So you're not confused about, oh, what version of this model am I using? And I've made changes and I don't know where they're lost. You want to ensure that your data, your models, etc., are what they claim they are. Do your best to avoid ambiguity, because then again, as I said, you're opening the doors for misinterpretation and misuse. Clearly define ownership, who owns what, who's built what, select appropriate licensing. You have to maintain the ethical and legal standards. You cannot share patient data, even de-identified without their consent, or some chain of consent that has been approved. Then it's also important to get continuous feedback. The more you engage the users and the larger community in your efforts, the more likely you are to ensure that it stays relevant with the work that you're doing lives on. And since a lot of the open source resources are built by smaller teams, they usually don't have the bandwidth to maintain the resources long term. So how do you so it's important that as you can bring in the community as early as you can during the process of building these resources, so you have proper feedback as you build this, and you're not building something that nobody's going to use eventually. It's also important that you clearly communicate what the issues are, what the limitations are, if you are making any assumptions, so when somebody else uses it, they know exactly what they're getting. I'll talk a little bit about the models that we built. They're not validated, and people have come back and questioned the simulation results, and we have to remind them that it's in the documentation that it says that these are not validated models. So it's important to remove that ambiguity when you're communicating what you're building. So again, you are avoiding misinterpretation and misuse of what you're doing. And don't overpromise. You have to be very clear about what the limitations of what you're doing. And then you have to provide as specifications and guidelines and as much details as you can, so you can facilitate reproducibility, which is, as most of us know, reproducibility is a huge challenge. You read a paper, you try to reproduce it, it doesn't work, information is missing. So it's important that when you are disseminating your work, that you're very clear about as much detail as you possibly can put in it, so somebody else can take that 10 years from now and can reproduce your work. So then coming to our own work, and then what motivated us to build and share knee modeling resources. So many of you in the audience, I'm sure, are familiar with the pains of building a model, a finite element model, and largely because a lot of the modeling and simulation is an art. It's not a mechanical process. It involves expert judgment. You need to make several decisions based on the context that you're building a model for the use case. Each of those may have an impact on the final outcome. So anything from how much anatomical detail you're going to need, to what material properties you're going to use, to what simulation strategies you're going to use, how are you going to validate the models. So the key is that the choices will depend on the question we're trying to answer. But even with that knowledge, many of these decisions can vary depending on the modeler. So essentially, it is hard. It also takes a lot of time, and it's expensive. So knee modeling is not new. People have been building models for decades. The problem is that most of, if not all, this work, most of this work is not reproducible. And then second, that since building these models is hard, just getting started can take a long time, even when you know how to do it. So if some of these models and related information is available, you can build on that. But when we started OpenKnees, there were no large data sets of models being shared. In fact, the OpenKnees Generation 1 was the first openly a publicly disseminated model of the knee when it was the first when it was first publicly disseminated. So then the idea of OpenKnees stemmed from there. The lack of availability of models, readily available knee models. So Ahmet and one of our engineers at the time, Scott Seibel, built the first generation model of the knee and disseminated, publicly disseminated that, and it has been used numerous times by others to enable their work. Then to take it to the next level, we decided to build a publicly accessible database of more models and more finite element models of the knee, but also provide everything that is associated with building those models. So all the derivative information that comes from that model. So again, as we know that finite element modeling is not trivial. It needs a lot of resources. It needs a lot of expertise to both gather the data that is needed to build and run and validate these models, but also expertise to then be able to actually build them from this data. So there's the foundational data in the form of the joint and tissue mechanical testing data, there's imaging data, and then these foundational data are then used to build, run, validate these specimen-specific models. So our goal was to be able to gather all of this data in-house and then build a database of specimen-specific finite element models. That's what we wanted to do when we started out. So over the next few slides, I want to talk about the effort that goes into building a resource such as this. I won't spend too much time on each of these, but I just want to give you a sense of how much actually goes into building models, and if you miss pieces of it, it becomes incredibly difficult to be able to reproduce these. And I'll talk about our efforts to how we make sure that anything and everything that we do is out there, it's clearly communicated, and we continue to engage the community to make sure that that what we're doing is relevant and makes sense and is useful. So we started, as I'm saying, a large database, but we started with 8 specimens. Even though it's 8 doesn't sound like a lot, and we tried to include as much diversity as we could into this cohort. So based on male and female, old and young, healthy and osteoarthritic. So we could capture sort of a wide variety of specimens, even in this small cohort. So the first thing that you do is you start with foundation data, and as we decided that we were going to get all of the associated data, whether it's the mechanical testing data or the imaging data, we were going to obtain that in-house, and the goal was to get as much comprehensive information as we could with the resources that we had, to be able to build our models. So for imaging, we gathered MRIs in 3 different using 3 different protocols. So one to highlight all the tissues, the general purpose, one to highlight the cartilage, and then one set to highlight the soft tissues. And then we obtained the pretty comprehensive mechanical testing data, both the tibio-femoral and patellofemoral joint, the combination of laxity and laxity loading and some combined loading scenarios, and some pressure measurement for the patellofemoral joint, using diverse quadriceps loading. So we had, and we did this for all of our 8 specimens. And we were a little ambitious initially when we decided that we are going to also characterize all of the tissues that we are going to build in this model at different locations for each of these needs. It turns out it is a very, very difficult problem to solve. As we started reading papers and started to reproduce the work that others were doing, we kept failing. And we realized that we had to take a step back and build our own protocols. And we were only able to do that for cartilage for one knee. So we developed reproducible, and we disseminated and published the study, and all the data and all the results associated with that, describing how we developed the protocols and how we tested and how we demonstrated the reproducibility of these protocols. So we had to take a step back here and then rely on literature to build our models, because we realistically couldn't cover all of the tissues, for all of the joints. Then once we had this data, the building models itself is a pretty long, complicated process. You start with your imaging data, you segment all the appropriate tissues of interest, you build the geometries, then you build your meshes, you build your template models, and you customize them, you run your simulations, and simulations don't run. You need to figure out why they're not running. So if in our case, like I mentioned earlier, we did not validate the models. What we wanted to do here with our simulations is to demonstrate that these models can run. So we used a simulated passive flexion to make sure that what we've built in all of these 8 models actually runs. And those are the results that we have then disseminated. But we also have all of this foundation data that somebody can take and use to validate these models. So even though this is a smallish data set, the digital assets that came out of this process of building the data is pretty huge and diverse and immense. If we have the geometries, the raw geometry segmentations, the round smooth geometries, the meshes, the models, the simulation results. We also have multiple iterations of some of these, and all of this is publicly accessible. So if you want to pick a model and tweak it to test whatever you're testing, if you're free to do so. If you want to pick a segmentation and just build your own models, you're free to do so. The important point here is that since we provided all of this information from beginning to end, it helps us to communicate that the trustworthiness of what we are building. Because at any point you can pick a piece of any of these and go back to its origin and confirm whether it makes sense or not. So the completeness of data is extremely important. It was extremely important to us. So, and we ensured that anything and everything that we're doing is then this provided to the community as we were building it. Like I mentioned, we didn't validate these models. We were also not, we didn't use any of the data to the joint mechanics data to run these either. So we only did a simulated passive flexion, and we don't have to go into the details of the results here, but I just wanted to quickly show that even within that, you see, you know, the diversity and the differences in between the different specimens. So everything that we've done for OpenKnees so far, all of the data, all of the mechanical testing data, all of the and the cartilage characterization study, everything of all of our models, everything, we've published this work, everything is out there. And most importantly, anything and everything associated with this project, whether it's right from our weekly meetings, minutes to all the data, all the models, all the intermediate components, all the extensive documentation and specifications, all the source code, we made a conscious effort to only use open source tools as we were building these. So from 3D Slicer for segmentation, or Salome, or FEBio, or using Python for coding. So if somebody else wants to pick up these specifications and wants to build their own models, they're not limited by what's available to them, because anything and everything that we've used is open source. So, and all of our work, pretty much all of our projects are hosted on SimTK. I'm sure most of you are familiar with it. And all of this, the data, all of the models and everything else associated with it is available on the data share platform of our OpenKnees project on SimTK. So then coming to why we did this, and you know, whether we succeeded in what we had started out hoping. So as you can see, since it's been made available, it has been downloaded over 150,000 times. And it has enabled over 50 studies. So not necessarily just by models. A lot of people have used the data or segmentations and, you know, geometries, etc. But it shows you the impact that even this small data set, that in the small database that we've built, the impact that it's had on the research since it's been disseminated. So I want you all to think about, you know, when you decide that oh, who's going to use this. This is, you know, I'd encourage you to look at this and tell yourself that, you know, what you're doing is valuable, and you should, if you're willing and you can, you should share your work, because that's how we can accelerate process and translation. A lot of these would not have been possible if they needed to actually get the data, etc., to enable their studies. They were able to do that because it was available through OpenKnees. So, of course, something like this you cannot build without a lot of people willing to pitch in. So this work is, a result of a very well coordinated, deep collaboration between a lot of people. That's why we need a community. These people are responsible for the impact this project has created and has enabled so many studies. So then, speaking of engaging community to address concerns that have lingered with, without any clear direction in sight, the reproducibility in the modeling is probably at the top of the list. Many of us in the modeling and simulation community have experienced firsthand the challenges of trying to reproduce somebody else's work. And you read a paper and you try to follow how they build their models, and you very quickly realize that some key details are missing, or there's some of their assumptions are not very clear. Essentially, they're not reproducible. So and then harnessing the expertise and experience that exists in our ecosystem, we decided to tackle that collectively. And I would like to point out that this again would not have been possible if we didn't have the open needs data available. And as we were building this, University of Denver also made some of their data and models available. So because of these two openly available data sets, we were able to prop up NEHub and then the work that I'm going to talk about in the next few slides. So the goal with the NEHub when the first time around was to understand, whether the predictions of, naturally biomechanics depend on modeling decisions of separate or different teams when the source data and the target simulation scenario are the same. So you give people the same data, several different teams the same data, and then you want them to simulate a certain scenario, and they're free to make the decisions that they make along the way, and then you see where everybody gets at the end of this exercise. So 5 teams are part of the study, and all of them are established knee modelers, and they've been doing this for years. And so we started with 2 knee specimens provided by the 2 teams, as I mentioned, open knees and the from Denver. And there was both the imaging and mechanical testing data available. That was at different phases, different data was provided to the teams. And then the study was divided into 4 phases. We started with building the models just with anatomical information. Then the calibration data was provided to tune the models, and then it was followed by benchmarking, and then finally the simulation scenarios to test model reuse. So the goal was to compare outcomes at each of these phases. So now before every phase, we're required to write clearly describe detailed specifications of all the modeling decisions that we were going to make in as much minute details as possible. And if you deviated from those decisions, then you had to document those decisions as well, and then submit them at the end of the phase. So all of the derivative data, the segmentations, geometries, models, results, code, all are either disseminated based on the phases, or they're in preparation of dissemination. So again, anything and everything that we've done for this project is either already out there for people to read and use, or we are in the process of making that available. So at the end of each phase, 5 packages containing everything associated with that phase were made publicly available, or will be made publicly available as we finish a couple of those phases. So so what did we find? So here are some of the outcomes. I don't want to get into the details again, but you can just visually see that there's a lot of diversity and a lot of differences in both the models and the results as they come out. You just visually, you can tell, the differences in the model components, the ligament representations, how well the geometries are identified. There's variability in the segmentation. It turns out that the teams use different imaging data sets. The origin insertions for ligaments are variable. So one team did not include the menisci in their models, and different software packages were used, different material models were used. And so there are very many notable differences. So this gives you a sense of just the diversity, because there's no standardization, and people are free to make the decisions they make based on their experience or tools available, etc. There's so much diversity exists that then it becomes very challenging to take this and reproduce it if you wanted to. if you don't have clarity on how things are done. That's why it was very important for us to describe every single thing that we were doing in minute detail. And then in the calibration phase, which I would add that we had to repeat because again, even though these teams are experienced and have been doing this for a long time, a bunch of us misinterpreted the data as when initially provided to us, and then we had to provide it, process it, and make it more digestible so everybody actually understood and we were on the same page. And there were market differences even the second time around, and the calibration strategies are also very different for how the optimizations were done for ligaments, how different calibration targets were used, etc. Again, I don't want to get into the details of what you're seeing here, but you can just see the diversity of the or just the differences in the outcomes of the models. And then we're currently in the process of wrapping up the benchmark analysis thing, or actually we just published it, and submitted, I shouldn't say published it, we just submitted the benchmarking outcomes, and all the packages would be, I think except for one, all the rest of the packages are already disseminated. And then for the last phase, we are wrapping up all of the outputs, and they will be disseminated hopefully soon. So, so what we learned is that these all of our different teams have been actively building models for years, and we still have a lot of variability. So the next best thing to come up with was to agree upon workflows, because there are no gold standards. So, and the point being that before we can trust the models as tools for any kind of decision making, we need to be able to reproduce them. So the goal then moving forward was to build consensus-based workflows. So relying on communicating with experts to create very clear, again, unambiguous workflows for a given context of use. So for a given use case. So in the second iteration of the NEHA project, there are two studies that we're conducting. One with the goal of engaging the larger expert community to build a consensus-based workflow, modeling and simulation workflow, again, as detailed as we can make it. And so the first task was to identify a context of use that the majority of expert panel is interested in. We have identified like 200 some experts that we will reach out to and engage at different stages of our planned Delphi study to come up with these workflows. And this is an iterative process. So based on that context, how that context of use emerges with this exercise, the following studies will then focus on, defining and identifying the workflow details specific for that context of use, whatever context that emerges from this exercise. So then started with first identifying the broad needs. So, what kind of data we'll need, what tissues we're going to model, et cetera, and then followed by, specifics of the model development, calibration, benchmarking, and then, how do you validate, how do you verify, and then most importantly, how do you communicate and report what you have built? So again, somebody else could take it, reproduce it, is not misinterpreting what you're providing here. And like I said, it'll be an iterative process, and we will send out questionnaires and we analyze the responses, and whatever comes out of this, we will, based on the majority, whatever the majority votes, we will go with that. And so we're hoping that with all of these experts bringing their knowledge into building these workflows, we will be able to come up with workflows that the majority agrees with, the end-to-end workflow that the majority agrees with, and then we will publish them, and hopefully other people can take advantage of that instead of, again, having to build their own workflows and starting from scratch. So then the second path we are taking is building a unified workflow. So the goal here is to identify one context of use, which we did, and then all the teams, the core teams here we have, we all agreed upon, and we're building that workflow collectively. So we meet every week. We decide what we are going to, what is the what is the next step in the workflow that we want to discuss, we decide. So whether it's the segmentation strategy, which tissues to include, etc. And we are right now, that's the process that we are in, and hopefully over the next 2 years we'll be able to build the workflow, the entire workflow, and 2 teams will be able to use that workflow to build the models, and then we compare what we get out of those. So again, I don't want to get into some of the details here, but one thing that I would like you to take away from this is that the goal here with NEHA is not to build a validated model. It's not to build, solve the clinical problem here. The deliverable here is the process of systematically engaging the community. We're building these guidelines on, learning. How do you learn from experts? Not only, what you learn, but how do you learn from experts? You systematically make decisions. How do you document? How do you communicate? So others can better interpret them as intended. So by making these models more reproducible, will allow whoever uses these to build either the models or the workflows to build on our work rather than reinvent it. So you're reducing duplication, you're saving time, you're accelerating research. So again, why share? Because it helps to accelerate progress. It removes duplication, it removes stagnation. And that's what we're doing. Again, this would not have been possible if it weren't for all of these amazing individuals who work really, really hard, and they will continue to work on this until we reach our goals. And we're very, very grateful that we were able to collaborate with all of them, and we'll continue to work with them. So the one last thing I want to talk about is as we're building on our experience with Open Knees and community engagement with both Open Knees, NEHA, and the variety of other projects that we work on. Last year we got an opportunity through NSF's Pathways to Open Source grant to build an open source ecosystem for computational biomechanics community. So the idea here is that we have this scattered, small but pretty diverse community of in biomechanics, whether it's academia, industry, regulatory bodies, professional organizations, what have you, and we all live in our own little bubbles, and which means that there's a lack of communication between these two. There's no clear channels of communication. There's no clear channels to collaborate. There are no clear channels to share the resources. There's no home for our community necessarily. So what we proposed with this is to build an open source ecosystem and an open source platform that will serve as a home to the computational biomechanics community. So the idea is that what you see here is a vision that we have, that based on, if we are able to build this platform, which we hope would have features that meet the most pressing needs of our broader community, then we will be able to, through continuous engagement, through the features and tools that we have built on this platform, or we will build on this platform, we'll be able to bring the community together, and we'll be able to really build a home and be able to connect everybody that exists in this ecosystem. Because what is the end goal? The end goal here is, you want to help patients, you want to help improve lives. And the path for modeling simulation to get to that is me in particular, is pretty long. But if we don't even agree on how we're going to build models, the trust in how are you going to build trust in clinicians and patients that you should trust these models for clinical decision making is a long ways away. So for things like that, you need to be able to connect people. So you need to be able to make sure that we are working towards the same goals, and for those we need to make sure that we have the right resources available. And for that we need to understand what those right resources are. So this is what we're trying to do with all the engagement activities that we have organized in the last year, whether it's one-on-one interviews with the variety of stakeholders throughout our ecosystem, PhD students, postdocs, early young investigators, established researchers, industry folk, people from the FDA. We've talked to a variety of people, and we've taken their inputs into account, and we have identified the things that we think that the community needs, and we are writing our phase 2 proposal now, and we're hoping that if this becomes possible, then we will have a home for our community to come together, build together, and solve the problems that we should be solving, instead of continuously regurgitating the same thing with somebody that redoing the work somebody has already done 20 years ago and not knowing what they've already done. And we're hoping that we can accelerate research and translation, and make things happen that actually need to happen, is actually help people and improve healthcare and the quality of life of people that we hope to serve. So so that's pretty much it about all the work that we are currently doing. And of course, none of this would have been possible if we didn't have the support from the funding agencies. So of course, most of this work is supported by NIH, and our open source platform work is being supported by NSF, and we are incredibly grateful for all that. And we hope that it will continue, and then we can continue to build and build the resources for the community, and be able to just work and build and progress together, and find solutions that and find answers that are still remain unsolved. And thank you so much for your time and listening to me today. And please feel free to ask any questions. We also have a workshop before I end this. I wanted to mention on August 10th and 11th to discuss further the requirements for the open source ecosystem, and we are bringing a bunch of leading voices in the community to come together and kibitz on what are the needs, what can we build, what is available, what are the gaps, and can we effectively, realistically build these solutions or pathways to these solutions through this ecosystem platform that we are hoping to build. And with that, I will end my spiel here. And if there are any questions, please feel free to ask. I can't really see anybody, so I might have to stop sharing.
That's great. Thank you so much, Snail. So again, if anyone has any questions they want to ask either out loud or in the chat. Allison, do you want to go ahead?
Sure. Hi, thanks for I think we've talked before, but thanks for the presentation. I'm just wondering, like, once you have these standards and workflows, how transferable would they be to models of other joints? Like, is it really specific to the knee, or is it something that applies to models in general?
I think the reason why we are, and Ahmet, correct me if I'm wrong, the reason why we want to focus on specific contexts of use is just because when we try to make something very general purpose, it fails. So the short answer is yes, we might be able to learn some strategies that we can apply to other contexts of use for the knee models first, and maybe other joints. But I think the efforts here are very focused on, can we build these workflows for a given context of use that we have identified, and would those work if two teams were to reproduce them, were to use those and build their models. So that's where we're first starting, and then because we want to build these and we have been writing these in as much detail as we can, then we're hoping that knowledge will be transferable to other joints as well, for some of that, not all.
Thanks.
In creating an open source data set like this, can you speak to efforts that you're making to have both specific but generalizable data? We know that male versus female anatomy is going to be different. So what efforts exist in there to make sure that this is a diverse but also comprehensive and unique data set as we use it?
Just trying to understand the question again. So are you asking whether how do we ensure when we build OpenEase? So as I mentioned, it's a very small data set, right? So we tried to capture as much diversity as we could with, male, female, old, young, healthy, old, osteoarthritic. So that was as much as we could do. But there's also the OEI data, the Osteoarthritis Initiative data that has like thousands of knees that they have gathered, MRIs over 7 years. So there's that exists. Of course, there are no models, there's no mechanical testing data, etc. But several groups have used that data to build their their modeling studies. So that was the best we could do with OpenEase, given the resources and how expensive everything is, right? From actually the specimens themselves to gathering the data, etc. So that's how we try to capture it, and we also have about 12 additional specimens that we've sort of adopted from another study. And we have the foundation data, both imaging and John mechanical data, not as extensive as OpenEase, but we haven't started building those models yet. So that's hopefully when we have the time and resources, and we might engage the community to take that and take our OpenEase specifications and build models using those.
Thank you. I have also added in the chat for folks who are interested, information for the 2-day workshop coming up and the registration links for that as well.
So thank you so much.
I'll ask one more question, which is that whenever any of us collect data, we always think like, oh man, once we're writing it, that we could have done better. Can you give an example of where you might have found that in this process, especially since this data has not only been used by you, but so many other individuals?
Yeah, the first thing that pops in my head is the imaging data. I think we probably should have done a better job of even though we made an effort to get the especially for soft tissues, for ligaments, etc. It was even though we had all these 3 different sets and then different planes, we started segmenting, we realized that we probably should have done a better job with like slice thicknesses and etc. when we gathered this data, because when you start segmenting, say MCL or LCL, they're really thin, they're really hard to see. So probably that's one example that I can think of. How about you, Ahmet? Anything else you can think of that just data-wise that we could have done differently? Because anything beyond that you can reproduce, anything beyond that you can rebuild, right?
Yeah.
So
I think not data-wise, but I think that our fundamental assumption that we learned actually with this process was, and Snell, you can take it from here if you remember it.
yeah, so it was funny and frustrating a little bit, because when we started out OpenEase, we were so confident that people want these ready-to-use models, right? Because that's what everybody needs, and that's how we built it. That's why there was so much focus on, hey, let's build models. So that was the assumption when we started out the post phase 1. Community engagement. We started talking to people. That's what our assumption was. Like, we thought that we were going to then take this and then using the post, the open source ecosystem, we can expand on that. So people will have access to all of these hundreds of models, fantasy. But then as we started talking to people, we realized very quickly that people didn't care about ready-to-use models. They wanted more fundamental data, more foundational data. They wanted clearly defined workflows. So our very structured ways to collaborate with others. So very clear, very quickly and early on realized that we probably could have shifted our focus a little bit on open knees. Not that we regret it. I think it's a we are very, very happy that we were able to do that. But I think we probably would have focused on sort of building a larger data set, and that's what we're trying to correct here with our with our plan to build this open source ecosystem to be able to have a home for diverse data where people can deposit their own data. So everybody else has access to a larger, collectively gathered resource, et cetera, and more understandable, clearly, workflows that you can follow easily, because a first year grad student, how they interpret something versus, a seasoned researcher interprets something is very different. So those are the needs that actually came out of these extensive, we talked to like 60 plus stakeholders from across the community, and we continue to do so. We have webinar series where we are trying to initiate these conversations, and you guys are invited to that. And we're trying to do the same thing with the workshop. We're trying to initiate these conversations to really understand what is it that we collectively need. We can't, not saying that we can meet all those needs, but it's important to really understand what we need. So we're not, we have this notion that we'll build and they'll come, but they don't come. So you have to really know what they want. So yeah, that was a very big learning experience.
Well, great. Thank you so much. I want to be mindful because we are at the hour. So thank you both Snell and Ahmet for joining us today and for sharing all of this incredible work that you've done. We really appreciate learning more about how open source data sets are made and also how we might implement these practices in the data sets that we collect to share beyond our own research.
Yeah, and if anybody has any questions, please feel free to reach out. We're always happy to engage and talk to you anytime. Yeah, and thank you so much for having us. This was great.
Thank you.